Explorer 1, the most far-off human-made test in space, has returned helpful information to Earth. This exceptional revelation overcomes all presumption and brings up issues about what lies outside our ability to grasp of the universe. Voyager 1 will leave the solar system and become a long-term space probe after passing Neptune. The Voyager missions have provided some of the earliest and most breathtaking views of the solar system's wonders for nearly 50 years. Interestingly, Michael Minovich came up with the idea in the 1970s that a spacecraft could reach the inner solar system by using the speed of a planet. These expectations have been met by Voyager's mission. In 1977, Voyager 1 and Voyager 2 were launched a few weeks apart with the initial goal of exploring Saturn and Jupiter. They were able to successfully study these gas giants before making their first close-up observations of Neptune and Uranus in 1989 and 1986, respectively. The straightforward Voyager spacecraft pursued a significant objective, more deep space exploration, rather than terminating the mission. Presently, after 46 years, Explorer 1 and Explorer 2 are as yet voyaging, gathering significant logical data from space. The first information about the heliosphere, the protective layer that surrounds our solar system, comes from NASA's Voyager 1 and 2 spacecraft. They have provided valuable insights into this shield through their work as online journalists. At a distance of 17.7 billion kilometers from the Sun, Voyager 2 entered this vast region in 2018. New insights into interstellar space have been provided by NASA's Voyager mission, including the discovery that cosmic rays are 3 times stronger outside the heliopause than inside the heliosphere's protective zone. To get a complete picture of our Sun and its intricate interactions with the interstellar space around it, scientists at NASA combined data from subsequent missions with Voyager observations. In 2019, Voyager 1 recorded a faint hum that was analogous to the vibrations that are produced by the tiny gases that are floating in the vacuum of interstellar space. Questions about our understanding of the universe and our place in it were raised by this unexpected discovery. The heliopause, which is the boundary between the influence of the Sun and interstellar space, is unpredictable, making the outer reaches of our solar system fascinating. Scientists used data from Voyager 1, Voyager 2, and NASA's Boundary Explorer interstellar space probe to find this phenomenon over the past decade. Even at a specific point in time and space, these observations provide precise measurements of the boundaries of the planet. Ongoing examinations have tested what we had some awareness of the heliopause with perceptions recommending the strange brilliance of fiery particles in 2014, demonstrating heliopause motions. These differences, on the other hand, did not match our previous models. After looking at the data from Voyager 1 and Voyager 2, researchers noticed that the heliopause position changed significantly for a short time. This movement makes sense of why 2 tests arrived at interstellar space in 2012 and 2018. Not only are these differences perplexing, but they also go against everything we thought we knew about the heliopause. These distinctions are referred to as controversy by scientists, indicating that they are contentious and cause confusion within the scientific community. In 2025, the Interstellar Mapping and Acceleration Survey, IMAS, is scheduled to launch, and its results are expected to shed new light on our solar system. During Voyager 1's normal operation in May 2023, the Communications and Control System, ACS, began transmitting ambiguous data, an unusual occurrence. Past updates on the well-being and status of the rocket appeared to be arbitrary or conflicting. NASA quickly identified the issue and discovered that ACS was transmitting data using a disabled computer. NASA is actively looking into the matter to keep things from happening again. For more than a decade, Voyager 1 has traveled beyond the Sun's protective magnetic field into interstellar space. The Explorer tests, which have been on a staggering excursion for almost 50 years, have been exploring through interstellar space, a climate loaded up with elevated degrees of radiation. These famous space apparatus have traversed huge distances, diving into obscure domains and uncovering historic information. NASA has successfully maintained the functionality of these far-off explorers by sending software updates across vast cosmic distances to ensure their continued operation, despite their technological limitations. Every celestial body the Voyager probes have encountered has left an indelible mark, providing profound insights into the mysteries of our solar system. They have discovered useful information about Saturn, Jupiter, and Io and Triton, Jupiter's moons. At Triton, hydrogen gas detonates at 40 degrees above outright zero on the Kelvin scale, which is astounding. The most exciting discovery is that alien life has been found on two of Jupiter's moon Europa and Saturn's moon Enceladus. Because these moons may contain living things, they should be the primary focus of exploration. In the early 1990s, Carl Sagan's Voyager imaging team came up with the idea to take pictures of our solar system, including Earth. This view has never been seen before thanks to the stunning sunrise photographs that were taken during the Apollo program. On August 25, 2012, Voyager 1 made history by traveling 11 billion miles from the Sun through interstellar space. Amazingly, it continues to provide useful data. It would take 22.5 hours for a radio signal traveling at the speed of light to reach Voyager 1 from Earth if Voyager 2 had begun its interstellar journey in 2018. 19 hours pass in Voyager 2. They move away from us by 3 to 4 light seconds per day. They will rely on NASA's Deep Space Network, which consists of 3 arrays of monitors strategically placed all over the world to ensure communication anywhere in the world. As explorers move further through reality, their signs blur to a weak murmur, steady with what cosmologists expect as explorers push toward the mission's end. All in all, the Explorer tests have given profound experiences into the secrets of our planetary group and gave new bits of knowledge into our spot in the universe. In terms of celestial mechanics, the Voyager mission was a game-changer. Michael Minovich found that a shuttle from Earth would speed up away from the Sun. Gary Flandreau demonstrated that the spacecraft launched in the late 1970s and early 1980s could use powerful aids to accelerate exoplanets through specialized observation. This revelation implies that Neptune, at the edge of the planetary group, can be arrived at in only 12 years rather than the anticipated 30 years. NASA got an opportunity right now. However, financial plan requirements diminished the monstrous excursion of the external nearby planet group. They went with a smaller trip between Jupiter and Saturn, which still cost $1 billion. Advanced instruments like cameras, infrared and ultraviolet spectrometers, atmospheric particle mapping sensors, optical polarizers, and nuclear magnetic resonance are on board the twin Voyagers. At first, these space apparatus should labor for a very long time. However, they surpassed assumptions and broadened their life multiple times. The mythic and scientific journey to the stars and beyond, known as the Voyager mission, was legendary. This mission is a first-of-its-kind foray into the unknown thanks to the stunning images of far-off worlds captured by these spacecraft. The brilliant record, broadly conveyed by Explorer, is a phonograph record loaded up with pictures, melodies, and sounds that address Earth, including recognitions and dialects. A divine message to all savvy creatures in the smooth manner, providing us with a brief look at cosmic knowledge and everlasting status. The Voyager mission is a symbol of our collective desire to comprehend our cosmic significance and our profound curiosity about the universe. Humanity has been able to investigate the enigmatic realms of interstellar space for more than a decade thanks to NASA's diligent work with these twin spacecraft. Not only have the NASA probes provided us with useful information about our solar system, but they have also revealed unusual and surprising aspects of space beyond our Sun. To send new instructions directly to the computers on the spacecraft that are programmed to understand machine language, NASA engineers use a combination of creativity and resourcefulness to create software updates over long distances. These updates are significant for the endurance of our bold space apparatus, taking care of different issues from fixing failing parts to tending to memory issues. Not only was the Voyager mission a voyage, but it also served as the starting point for numerous trips across stars. They found space ages and empowered further investigation into space. NASA's enthusiasm for the Voyager mission led to the launch of 2 major missions, Galileo in 1989 and Juno in 2011, which revealed the intricate nature of Jupiter. NASA's Dragonfly mission, which is scheduled to land on Titan, Saturn's largest moon, in 2034, and the Europa Clipper mission, which is scheduled to explore Jupiter's moon Europa, which was first discovered by Voyager, in 2030, continue to build on Voyager's legacy across our solar system and other distant star systems. In addition, the review by the National Academy of Planetary Sciences suggested sending a $4.2 billion probe to Uranus in the 2040s, which would be a significant encounter with the enigmatic ice giant and its moons. The missions of Explorer 1 and 2 put into high gear a chain of interest and revelation that proceeds right up to the present day. Both Voyager 1 and Voyager 2 are still connected to the deep space network of NASA, where they can receive instructions and send data back to Earth. The arrangement is to proceed with interstellar investigation for another 5 or 6 years, yet in the mid to late 2020s, the space apparatus science instruments will be switched off, shut down, and dropped.